This session is going to be about noble gases. These gases were found in the 1890s, so they're one of the latest groups to go into the periodic table. What we're going to learn about them today is descriptions about why they're inert. We're going to link their uses to the properties. And finally, we're going to look at boiling points and densities in the noble gas group. We say that the noble gases are inert. This word means that they're unreactive. The reason why they're unreactive is because they always have full outer shells. There's only one shell needed for helium, and it's complete with 2 electrons. Neon has 8 electrons on its outer shell, so it's full. Argon has 8 electrons on its outer shell. It doesn't need to gain or lose any electrons. It's chemically stable. For your exam, you'll need to know the uses of noble gases and how they link to properties. 2 common properties that all of them have is that they're non-flammable. They don't catch fire. The second common property that they have is that they all glow when you pass electricity through them. Right, there's a box around some key ones that you'll need to know for your exam. These come up often in exams. Okay, so helium is the first in the group. Helium is used in airships and air balloons. Before helium being used in airships and air balloons, we used to use hydrogen. That was highly flammable. One of the reasons why we use helium is because it's non-flammable. It's also less dense than air, so it floats really well. Neon is used in advertising signs because it glows when you pass electricity through it. You can change it to whatever color you want. Argon, this has a box around it, so you need to know this for your exam. Argon is used in filament light bulbs. It prevents oxygen from reaching the filament and causing it to explode. The argon is used because it's inert. Krypton is used in laser eye surgery. Xenon is used in headlamps for cars because it burns really brightly, or it glows really brightly. And radon is used in cancer treatment. It's an extremely rare gas. You will be asked questions about density and boiling points. If we look at the densities of this group, as we go down the group, they get denser. And this is quite easy to understand because the number of neutrons, protons, and electrons are increasing in their structure. So if they've got more matter in them, their density should increase. The boiling points also show a similar trend. As we go down the group, the boiling point increases. Helium has the lowest boiling point of any element on the periodic table at minus 269 degrees Celsius. If you look at xenon here, it has a boiling point of around minus 107 degrees Celsius. Radon, which isn't on this graph here, has a boiling point of minus 62 degrees Celsius. They're all gases before they reach room temperature. Room temperature is about 25 degrees Celsius, so they're well below that level